So if you're having some trouble understanding how to use proportions to find missing variables on similar shapes, I wanted to create this video real quickly to help with that. So I want you to notice that in similar shapes, every side is similar, meaning it is proportionally built the same, just on a scale of smaller or larger. See where A to B is such and such, E to F is the same. Now, this question is asking you to find, in this similar quadrilateral, the length of AD. Now, AD is similar to EH over here. So we actually have a basis off of which to be able to calculate this. Because if AD and EH are similar, it means that they are proportionally distinct. So we have to be able to create some equations in this regard. Okay, so first we need to find two sides that match in this similar triangle, and we're going to go with DC and HG. And we can create a fraction using DC and HG. So let's go HG over DC. Another way to write that, of course, since we know their lengths, is we can say that it is 3 over 6. And of course, we know that 3 over 6 can be reduced to 1/2. So when I take two sides and I compare them in a similar triangle, I can find the scale or proportion to which these two similar shapes are proportional to. So this shape is going to be half of this shape. So now I have my scale. That's great. So what I can do now is I can take two sides and say HG over DC, right, is going to be the same scale and the same size. We can do two other letters. So we're going to take our EH and EH here on the other side over AD. Every set of sides is going to come to that same similarity. All right. So what am I going to do here? Well, I'm going to replace this HG with the 1/2 because we already figured out that it equals 1/2, right? And now I'm going to plug in here what I can. EH I know is 5 centimeters, right? But I don't know what AD is. So I'm just going to put an X for AD. Now I'm going to solve for the X. And what I can do here, and the beauty of this is that I can now use cross multiplication to determine what X is. So I can, let me just use a different color here so we can distinguish this. So I can cross multiply here, right? 1 times X, and here 5 times 2. So when I do this cross multiplication, what do I get? I get X, 1 times X is X, equals 5 times 2 is 10. So what is X? X in this case is going to be 10. So I know that AD equals what? 10. And that is the method that you will use to calculate how to figure out these things. So let's take a look at another one. Let's look at this one. We're going to, again, follow the same format. We know that ABCD is similar to EFGH. And again, similar means that they are proportional. They will reduce, if you compare one side with another on any given set, it will always reduce down to the same thing. And the question here is that we need to find FG. Now look, it's this triangle this time. This quadrilateral, the shape over here this time. We know that FG is going to be similar. It's going to match with this side on the similar triangle. And we can use, again, this same idea. We can take the DC, which is what? Works with the HG. You know what? Let me use a different color. Let's try this again. Let me distinguish this. We're looking for FG, and we know that it is matched with the other side of BC. And so if I switch up my colors now, again, I already know that DC and HG are similar. We already went through this before, right? We went HG over DC, right? We know that it's 3 over 6, right? And I know this is the same thing we did before, but I'm just reminding you, over 1 over 2. You have to find the matching side. Now, I cannot, keep this in mind, I can't go HG and AB, right? Because they're not the same. When you're matching up, you have to find the same exact pair, right? They have to match exactly. So in this case, HG will only work with DC. It won't work with anything else. So it's very important that you keep that in mind. But again, HG equals DC. We know this. We can figure this out. Let's get rid of this now. Okay. So what we have determined is that the scale of our shape here is the proportionality is 1/2. Right? So I could create a fraction for any one of these and it would always equal 1/2. For instance, if I were to go AB over EF, it should ultimately equal 1/2. Okay. Now, in this case, I know AB, I don't know what AB is, so I'm going to go X, but I do know what EF is, so I can go 4.5 equals 1/2. Whatever this X is, it's going to have to be able to be such, the numerator here, fractions that it will reduce down to 1/2. Well, let's go ahead and work this out now. Again, we'll do our cross multiplication, right? So X times 2 is 2X, and 4.5 times 1 is 4.5. Then I have to divide both sides by 2, right? And that's going to tell me that X equals 4.5 divided by 2. I'll give you 3 seconds to figure that out. Ready? Can you tell me what that is? If you were to divide 4.5 divided by 2, Lord willing, you came up with 2 and a quarter, or 2 and 1/4, or 2.25, right? So how does that work? So let's check this now. All right, let's take a different color here and check. So I'm going to work off of this, right? So my X should be 2.25 over 4.5. We'll go 4.50. Does that reduce down to 1.5? Wow, that's a great question. So how many times does 2.2? Well, let's see. 2.25 times 2 actually equals, ready? 4.50. How about that? How about that? So 2.25 goes into 4.51 twice. So we can reduce it down to 1/2. And that will be the principle that will apply for every single one of these. So let's solve this one real quickly and figure this one out together, shall we? So we want to find FG. Well, FG corresponds to the BC. And so therefore we know that X over, which is FG, X over 8, or FG over BC is always going to equal what? What's our scale? We know based on HG over DC, 3 over 6, which is 1/2. Well, again, we just solved for X. So we've got 2X, because we're going to cross multiply, right? 2 times X is 2X. 1 times 8 is 8. So and we're going to divide both sides by the coefficient of X, right? So now we know that X is, get rid of the 2's, 2 goes into 8, 4 times X equals 4. And that is how you find the missing side in a set of similar shapes when you use proportionality. I hope that helped, and I hope that you will enjoy continuing on doing all this great math. God bless.